Hey everyone, and welcome to the course. My name is Daniel Buckley, and I'll be your instructor. So in this course, we are going to be looking at learning the Unity game engine. Okay, Unity is a game engine, which basically means it is a tool that we can use in order to create pretty much whatever sort of game we want to make. Okay, so let's look a bit at Unity. Now, Unity is a cross-platform game engine which is used by millions of people around the world. Okay, it is the most popular game engine, and more than half of the mobile games you see on the App Store were created using Unity. So, Unity also is very versatile, and this basically means that we can create any sort of game ranging from 3D to 2D, mobile, console, multiplayer, virtual reality, and even augmented reality games, okay? And along with all these different things that we can create, Unity also allows us to build to pretty much any platform you can think of, okay? Android, iOS, even if you want to build to Microsoft VR headsets, okay? Unity has the tools available to do that. Now, what are the goals for this course? Well, first of all, we want to learn the Unity editor, okay? This is a piece of software that we need to get accustomed to, and we also then need to look at all the different features that Unity has and that we can use in order to develop our games, okay? So we'll be looking at each of these individually so that by the time we reach the end of the course, you yourself are rather familiar with the engine and you're comfortable with using it. Zenva is an online learning academy with over 1 million students. We feature a wide range of courses, for people who are just starting out or for people who just want to learn something new. The courses are also very versatile, allowing you to learn in really whatever way you want. You can choose to view the online video tutorials, read the included lesson summaries, or follow along with the instructor with the included course files. Now let's get started with our first lesson. Hey everyone, and welcome. In this lesson, we are going to be looking at installing the Unity Hub. Now, this is basically a program which allows us to manage all of our different Unity projects as well as different versions of the Unity editor. So let's hop over to unity.com and look at how we can begin. So here I am at the unity.com website. And pretty much what we want to do is go down to where we have this blue download Unity button. Okay, we're going to click on that, and that is going to navigate us over to the downloads page. Now, you should see then a download button here. For me, it says download for Windows, but if you're on Mac, it should say, download for Mac OS. So I'm just going to click on that, and it is going to begin downloading the installer. Okay, and once that's done, we can open up the installer and begin setting it up. So, first of all, we just want to click on I agree. We then want to choose a location to install the Unity Hub to. Normally the default location is probably the best. Then click install, and that's going to begin the process of installing it. And once that is done, you should see we have the completed setup page right here. Make sure to enable Run Unity Hub, click finish, and we should then have the Unity Hub open up for us. Okay, and when the Unity Hub opens up, you may have this little pop-up appear. We're not going to install it this way because for some people it may not appear, so we're just going to click on Skip Installation at the bottom right here. And you'll see initially that we are at the installs page, okay? So if you're not here, you can go over to the left-hand side on the navigation panel and click on Installs right here. And this is basically where we are going to have all of the different versions of Unity installed for us, okay? Right now, of course, we have nothing, so let's install Unity. So I'm going to go over to the top right corner of the screen and click on the Install Editor button right here. And that is going to open up this window, okay? Now, what we want to do is we just want to find the most recent long-term support version of Unity, okay? So right now I've got 2021.3, which was released now in 2022, and you should see it says recommended version, okay? So find the recommended version, click on the install button here, and that is going to bring us over to the modules page. Now, Unity doesn't have all of the build platforms installed by default because it takes up quite a large amount of space. So if you do want to build to Android or iOS, you can enable them right here. Or later on, if you want to change your mind and you might think later on, okay, I want to build to Linux now, for example, you can come back to the Unity Hub and install the modules afterwards. Okay, we're not going to install any modules now, but we do need to make sure that we have Microsoft Visual Studio Community here enabled, because that is going to be the program we use in order to write our code. Okay, so we need that enabled, of course, and that is around 1.2 gigabytes in file size, and in total it should be around 6 gigabytes. Okay, so make sure you have enough space available for that, and we're going to click continue. We then need to accept the Visual Studio Community License terms and click install. Okay, and that is going to begin the process up here. Now, since it is around 6 gigabytes in size, it may take some time depending on your internet and computer speed. So wait for that to finish and then continue on with the next lesson where we look at actually creating ourselves our first project. So I'll see you all then. Welcome back, everyone. In this lesson, we are going to be looking at how we can create a new project inside of Unity. Okay, so let's go ahead and open up the Unity Hub. Now, inside of the Unity Hub here, in the previous lesson, we went over installing our version of Unity. So we have the editor now installed. Do make sure that is complete before you continue on with this lesson. Now, depending on the size of the editor, it may be a couple gigabytes. That can take quite some time, so do make sure that the editor or the install has completed. Now, what we can do is we can go over to the Projects tab right here at the top left corner. And inside of the Projects tab is where we have all of our different Unity projects listed out. Now, you can see I already have some right here, but for you, it will most likely be empty. So how do we go about actually creating a new project? Well, we want to go to the blue button at the top right corner, which says New Project. We'll click on that, and it's going to open up this window right here. Now, inside of this window, this is where we want to basically choose a template. Now, a template is sort of the way that Unity sets up the editor for us to use. The two main common ones are going to be 3D, which is already selected for me, and 2D, okay, because Unity can create both 3D and 2D games. So basically, if you want to create a 3D game, you click on the 3D template. If you want to create a 2D game, you can click on the 2D one here. Now, if, for example, you click on the 3D template, you open up the editor, you start making your project, and then you're like, I actually want to make this a 2D game. Well, Unity doesn't sort of like lock you off from doing that. Rather, all these templates are just Unity changing some settings that you can, of course, go ahead and change yourselves in the editor. So you can easily make a 2D game with the 3D template if you wish, but it's just a bit easier since Unity sets some stuff up for us already. Okay, so don't think of templates as different versions of Unity. More so, they are all the exact same version of Unity with just a little bit of different things done to them before we get to actually create our game. So I'm going to click on the 3D template right here. And then on the right-hand side, we can give our project a name. I'm going to call this one Intro to Unity. And then we can choose a location for this project, okay? And you can have a dedicated folder on one of your drives if you wish, or wherever you want. So once you have a name for your project and a location assigned, we can click Create Project, and that should close the Unity Hub and open up the editor. And after around a minute or two, the Unity editor should open up, and now we can begin creating our games. Hey everyone, in this lesson we are going to be looking at the Unity editor, and we are going to basically see how it works and how we can navigate around it. So let's look at the Unity editor. Okay, now upon creating a brand new Unity project, you're probably looking at this and being a bit overwhelmed, okay? There's lots of buttons, lots of different windows, lots of different inputs and all that, and probably a lot of names and labels that you don't really understand, and that's entirely fine, okay? In this lesson, we're going to go over each of these windows and basically see what they are and how do they serve us in creating games. So, when you open up Unity, you should have this default layout right here with these different windows visible. Now, what is a window? Well, in Unity's terminology, a window is basically like a little panel. As you can see here, there are these individual segmented rectangles, and each of them serve a different purpose. Okay, you can see over here we have a little tab which says its name. We have the hierarchy, we have scene, we have project, and we have inspector. And over here on scene, for example, you'll see that there is also a little other tab. It's a bit like a web browser where we can switch between two different tabs, scene and game. And game is basically where we'll be playing our game to test it out. Same thing for down here in the project window. We have project and then we have console, okay? So what are these windows? The hierarchy basically lists out all of the different objects that we have in our current scene, okay? You can see right now we have a scene name, which is sample scene, and we have two objects, okay? We've created a new Unity project and we are basically given a bare bones scene to contain our game. And we have a main camera, which is basically what our game is going to be rendering to, and a directional light. Now these two objects are here by default, and look what happens if I click on the main camera, for example. I'll click on it and you'll see a few things happen. First of all, over here in the scene window, okay, which is known as the scene view, we have the camera selected, okay? You can see over there, we have that camera selected and we have this weird looking thing on top of it, which we'll go over a bit later. And as well as it being selected in the scene view, we also have the inspector window over here change quite a bit, okay? And now the inspector basically is listing out all of the different properties and components that this camera has, okay? So the hierarchy lists all of the different objects in our scene, and the inspector basically inspects whatever object we have currently selected, okay? So if I click on directional light, you'll see all of a sudden the inspector changes, and now we are looking at all of the properties on the directional light. And you can also see over here in the scene view that selection changes as well. So we've got the hierarchy where we can select our objects. We have the scene view, which is basically like us looking into our game world where we can see all of our objects. And we have the inspector, which basically has a closer, more finer look at whatever object we have selected, so we can look at its different properties, and we can of course go ahead and modify them, okay? For example, if we want to make the camera's field of view larger or smaller, we can modify that property right here. Something else is that we can also select objects directly in the scene view. Now, it may be a bit hard, but you can see there is this little sun icon right here, and this sun icon is there to represent this directional light. Now, we can select that directional light by clicking on it inside of the hierarchy here, or we can go ahead and click on that little icon in the scene view, and that basically does the exact same thing, okay? We have the properties in the inspector, and we can modify them there. But what is the project window down here, okay? The project window or the project browser is basically the file explorer for our project. Whenever we created a new project for our game right here, what we have basically done is created a new folder somewhere on our computer. And that folder basically is going to contain all of the files and all of the assets that we'll be needing for our game, okay? So you can think of it like all of the textures, materials, 3D models, sprites, sound effects. Now, you can see by default, we have one folder here, okay? Our scenes folder. Now, what we can do is we can just double click on that folder to open it up. And when it opens up, you'll see that we have one file right here, okay? We can click on it, and you can see that is called sample scene.unity. Now, the way that Unity actually organizes itself is in what's known as a scene. And a scene is, you can think of it like a level, okay, where you have sort of your self-contained environment, and you can have multiple scenes which sort of act, yeah, like I said, as levels. And we'll go over that a bit later on. You can also navigate your project files over here on the left-hand side, where we can click back on our assets folder, which is the root folder. And we can also go ahead and create new folders. For example, we can right-click, go create folder. That will basically create us a new folder here. And if we wanted to import some sound effects, for example, we could open up a window, like a file explorer, and just drag them in, okay? Just drag them in here, and they will import. Now, also next to the project tab here is console. And the console window is basically there for us to see any sort of messages that the editor wants to tell us. So for example, if we're playing our game and there's some sort of error in our code or error in the way we set up an object, it will log a message to the console explaining what the issue is. And finally, we have the game window, okay? And the game window is basically where our game is going to be rendered, okay? What you see right now is basically what our main camera over here is seeing, okay? If we click over into the scene view, you can see our main camera over here. It's kind of hard to really understand what's going on because we don't really have any physical objects in our scene. But yeah, the game view is basically showing us what our main camera is seeing. And what we can then do is go up to the top here and click on the play button, okay? You'll see there are 3 buttons. We have the play button, the pause button, and the step button, okay? So if I click on the play button, that's going to basically gray out the editor a bit, and now our game is playing, okay? So if we would have objects, if we would have some sort of controller, we'd be able to, play our game and test it out. You can click on the pause button here to pause it in case you want to pause an action in time to go change something or go check something. And then we have the play button to basically stop playing the game. And then when you're playing the game, you can click on the step button right here to basically go forward 1 frame at a time. But I don't really find myself using that function too often, okay? It's mainly just the play button and the pause button. So again, when you're in the play mode right here, you'll see that the screen has sort of gone a bit darker, and the play button is now blue. And if you click on the blue play button, it will stop playing the game. Now, something else I want to show you is the fact that the Unity editor is very customizable, okay? These aren't all the windows that you will be using. In fact, you can go up to here at the top, click on window, and you'll see here how many different types of windows there are. There's windows for animation, audio, AI, setting up UI and everything, okay? There's plenty of different windows, but how do we actually move them around? Okay, well, pretty much what we can do is just like with a window on your computer, you can click and drag on the sides to basically resize it, okay? So as you can see here, I can click on the edges of these windows to resize them. I can even, for example, click and hold on one of the tabs of the window here and drag it out, and it drags out into its own individual window. I can then go ahead and dock it. As you can see, it sort of automatically snaps wherever I'm dragging, so I can chuck the console up here. But for me, typically, I like to put the console next to the project window here, okay? So we have both the project browser and the console visible at all times. And I do like to make my inspector a bit wider just because there is a lot of information that we need to display. Okay, so that is a look at the Unity editor right here. Now, one more thing, and that is if your editor, if you're messing around with some windows and you accidentally close them, and you want to go back to the default. If you want to go back to the default layout, you want to go to the top right corner here where we have the layout drop down and just click on default, and that is going to swap you back to the default layout. But I'm going to get the layout that I like with the console over here on the side and the inspector window a bit wider, like so, and there we go. So feel free to explore the Unity editor, move around the windows, and get ready for the next lesson where we start looking at how we can actually navigate around our scene. So I'll see you all then in the next lesson. Hey everyone, in this lesson we are going to be looking at scene navigation inside of Unity. Now, scene navigation is basically the way that we can control the scene camera in order to build our levels. So let's hop over to the Unity editor right now, and what we're going to do is we are going to be looking at this center scene window right here, okay, the scene viewport. Now, the scene viewport is basically our eyes into our game world, okay? We also have the game view right here. Now, the game view is a bit different. The game view is what our camera object here is seeing, okay? And this, in turn, is going to be what our game is going to look like when we press play. Whereas the scene view is basically a way for us to fly around, select objects, move them around, and just overall build and construct and modify our levels, okay, here in the editor. So how do we actually do all of that? Well, first things first, what we can do is if we have our mouse over the scene view, what we can do is we can hold down right mouse button, and you should see that your mouse cursor turns to this little eyeball icon. And what we can then do is we can just look around as if we are playing a game, okay? So we can hold right mouse, look left, up, down, and right. Okay, so it's pretty cool that way. So we can look around. Now, what about moving? Well, if we hold down right mouse and we are looking around like so, while we are doing that, we can use the W, A, S, and D keys to fly around. Okay, so W to go forward, S to go back, A to go left, and D to go right. We can also move vertically, so if we press E, we can go up, and Q to go down. So using those 6 buttons, we can basically fly around our scene here, and as you can see, we don't really have much to look at, so what I'm going to do is I'm just going to quickly add in a new object, and that is going to be a cube. So the way we can do that is by going over to our hierarchy right here, and you'll see at the top left of the hierarchy window, there is a little plus. So I'm going to click on that, and this is basically where we can create all different types of objects for Unity. So I'm going to go over 3D object and I'm going to click on cube, and that is going to create a brand new cube in our scene right here. You'll see it pops up in the hierarchy. We can select it. You can also see that with 3D models inside of Unity, in the scene view, they have a little orange outline whenever we have them selected, and we have all the details here inside of the inspector. So we have our cube there just as a bit of a reference for us to see when we're flying around. Now, what happens if you are, let's just say, on the other side of your map working on something, and you're like, all right, I want to go back to the cube. Well, you could, of course, hold down right mouse and fly over there, but a much quicker way is if you know what the object is that you want to go to, you can select it here in the hierarchy, okay, you'll see it's highlighted blue, and then you can press F on your keyboard, and that is going to focus in on the object, okay? So we could be over here, press F, once we have an object selected, and we'll focus in on it. I can select our main camera now, press F, and we'll focus in on the main camera. Same thing for the directional light. Now, while we've been doing this, you've probably noticed that we have this little gizmo at the top right corner of our scene view, okay, and it sort of rotates whenever we look around. Now, this is what we call the scene view orientation gizmo, okay, and this basically allows us to quickly orientate the camera along certain planes of view. So let's just say we wanted to have a bird's eye view of our level, okay, we could of course, fly up, look down, but it's not exactly 90 degrees down to the ground, so what we can instead do is click on the green sort of arrow here, the green little nozzle. We can click on that, and it is going to automatically put our camera in the air and point us down. We can then click on the red one for the X orientation, and that is going to have us in a side view. Same thing for the blue one for the other side. And we can basically just flip our camera around these different directions. Now, also what we can do is click on the center square. And what this center square does is it changes the perspective view of our camera, okay? Because right now our camera is working like every other camera in the world, which basically captures depth, okay? You can see if we look at the cube here, the further away from the cube we go, the smaller it gets, okay? That makes sense. But what this little button does is it can toggle our view to, instead of being perspective view, we can turn our view into orthographic. So if we click on this little cube here, as you can see, all of a sudden our view has changed and we have this sort of view now, which basically makes it so that there is no depth, okay? No matter how far away an object is, it will always remain the same size. Now, when might you want to use this? Well, typically you'd use this for 2D games because 2D games don't really have depth per se. Or if you are maybe constructing some things in your level and you want really fine adjustments and you don't want perspective and depth to get in the way of that, you can of course toggle the orthographic mode in order to get this. And also what you can then do is hold down middle mouse to sort of drag the camera around whatever plane your camera is facing. So for example, if I'm on this rotation, I go hold down middle mouse and drag, and it sort of just pans the camera left, right, up, and down, okay? So we can then click that cube again to go back into perspective mode and bring back our depth like so. And yeah, that is just a few of the controls that we can use here inside of the Unity scene view to navigate around, okay? Once more, we can hold down the right mouse button to look around. While we are holding right mouse button, we can also use the W, A, S, and D keys to fly around, like in a video game. and then we can also use the E and the Q keys to move up and down. We can also hold and drag middle mouse to sort of pan the screen around like so. And we then have the orientation gizmo over at the top right corner, which allows us to change the orientation of the camera as well as the perspective, okay, like so. And finally, if we have an object selected, we can press F on our keyboard to focus in on them. So yeah, mess around with those, get comfortable with the controls, and in the next lesson, we are going to be looking at the concept of game objects. So thanks for watching, and I'll see you all then. Hey everyone, and welcome back. In this lesson, we are going to be looking at game objects. Now, let's hop over to Unity and begin learning what these things are. So, with Unity, game objects are what you could call the fundamental building blocks of games, okay? Game objects are what make up all of the different entities inside of your game, okay? Everything from the lights to the cameras to the player to the 3D models of the rocks and trees, the environment itself, and everything you can interact with is a game object, okay? Now, that's quite a abstract view of what they are. So let's have a look at some examples. So in our scene here already, when we create our new project, you'll see that in the hierarchy here, we have a main camera and a directional light, okay? And these are what are known as game objects, okay? We have a main camera game object and a directional light game object. The main camera is in charge of rendering what it sees to our screen, and the directional light is in charge of illuminating the environment. Now, if you click on these objects, you'll see that in the inspector, we can see their properties, and they are sort of divided up into these individual little sections, okay? You can see if we select our directional light, you see we have this little section here called transform, which we can sort of toggle open and close, as well as light. Now, these are what are known as components, and components are what give game objects their individual gameplay behaviors, okay? At its core, a main camera and a directional light are the exact same thing. They are a game object with a name and the ability to enable it or disable it. But what makes them individual is the different components that we assign to them. You'll see that on our main camera and our directional light, they both have a transform component, okay? And every single game object has the transform component by default, and it must have it, okay? A transform component is basically the fundamental foundational component that is required, and this basically gives that object a position, rotation, and scale in 3D space. And then from there, we can add a light component, for example, to have this object illuminate stuff, which is what our directional light does. Or in the case of our main camera, we can add a camera component, which renders whatever it sees to our screen, and an audio listener component, which allows it to hear sounds. Now, let's look at some different types of game objects. What I'm going to do is I'm going to go over to the hierarchy here, and I'm going to click on this little plus icon, okay? And this allows us to create a number of different game objects, okay? You can see 3D objects, we have stuff like cubes, spheres, capsules, effects, we have particle systems, trails, lights, we have all our different types of lights, audio, video, UI. There's tons of game objects inside of Unity and even more components. So what I'm going to do is I'm going to go over to 3D object, and I'm going to create ourselves, let's just say a sphere, okay? You'll see here, what happens is when we create an object, it gets added to the hierarchy, and we can actually give it a name. So I could call it something like my new sphere. Press enter to assign the name. You can see the name does also change in the inspector here, which we can of course click to modify at any time. Now this sphere, if we select it, you can see over here in the scene view, it is highlighted and it is selected. So over in the inspector, we have the list of components which make up and basically define this sphere object. So of course we have the transform component, which gives it a position, rotation, and scale in 3D space. That is a requirement. But you'll also see that we have 3 other components, and these 3 components are there by default. You can remove them, you can add more as well. For example, the mesh filter component, this basically just defines which 3D model this sphere or this game object is going to be rendering. So if we click on the little circle next to this property here, what we can do is change it to a cube, for example. And you can see here that our object is now cube, but let's change it back to a sphere. So that's what the mesh filter does. Then we have the mesh renderer, and this basically defines all of the settings for rendering it to our screen, okay? So what material is it going to have? Is it going to cast shadows? Is it going to receive shadows? And a bunch of other lighting related settings. And then finally, we have the sphere collider component, and the sphere collider component basically makes this object solid, okay? So if we would have physics, or if our player was running around our level, they would basically hit this object and not be able to pass through it. So that is generally how a 3D model is composed with components, okay? And you can see how it differs from our directional light, for example, okay? They look totally different here in the scene view, and the sphere, of course, has a physical representation. They all are fundamentally the same thing. They are all game objects. The only difference is the components that we assign to them. And to show that even more, I can click on our sphere here, for example. We can go down to the Add Component button right at the bottom here. And the Add Component button, if we click on it, it allows us to go ahead and basically add a new component to this game object. So we can scroll through the list here, we can click Open, and you can see if we keep just having a look at these different things, there are lots and lots of different components to attach, okay? So let's just say on our sphere here, we want it to emit light. What we can do is we can just go to the search bar here and type in light. And you'll see here we have the light component. We can click on that. And now it may be a bit hard to see just because we don't really have a floor or any other environment, but our sphere is now emitting light, just like the directional light is. So you can see that we can just attach pretty much whatever components we wish to any game object, okay? If we want our sphere to be able to emit light, we can. If we want our sphere to have physics, we can attach a rigid body component. If for some reason you wanted your directional light here to have a collider, we could of course go Add Component, look for a sphere collider, and attach it like so, okay? And you can see we have this green outline of the sphere collider. Now how about removing components? Because you probably don't want a collider on your directional light. So what we can do is we can go over to the inspector, and you can see that there are these 3 little dots next to the component. So we can click on those and just go Remove Component. Okay, if we want to remove the light on our sphere, we can do that. Or to make it a bit faster, we can just right click on the component header here and go Remove Component. And there we go. So that is a quick look at game objects inside of Unity and how they are basically made up of by components, okay? Game objects are the building blocks of every single object and entity in your game, and the components are what make those game objects individual and give them their gameplay behaviors. Thanks for watching, and I'll see you all then in the next lesson. Welcome back, everyone. In this lesson, we are going to be looking at how we can move our game objects. Okay, so we're able to create them, we know what they are, but how do we actually move them around our scene to place them where we want them to? Well, first of all, we need to look at Unity's coordinate system, okay? Now, what is a coordinate system? Well, a coordinate system is necessary in order to pinpoint a specific position in 3D space, okay? We have a game object in our scene. Where is it? Okay, how do we define its position in our scene? Well, we do that with an X, Y, and Z value. Just like if you were to plot a graph, you need a horizontal and a vertical axis. Yet in 3D space, we have 3 different dimensions, so we need 3 axes in order to position correctly an object in 3D space. Okay, an X, a Y, and a Z value. Now, let's hop over to Unity and have a look at how we can do this. So if we select our main camera, for example, here in the hierarchy, you'll see that over in the inspector, over in our transform component, we have a position property, okay? And the position basically defines the X, the Y, and the Z axis, okay? And altogether, that is our position, okay? Now, look what happens if I change, for example, the X axis here to 1. You can see that our camera has now moved. We can go to -1 and it moves back, okay? If I change the Y to something like 3, you can see the camera moves up. Now, let's go ahead and create ourselves a game object. So I'm going to do is I'm going to right click in the hierarchy here, and I'm going to go 3D object, cube. Okay, I've created ourselves a new cube right here. You'll see that we have this 3-arrowed little overlay, and this actually looks similar to the diagram we had just in the slides. And this is what's known as the move gizmo, okay? And this basically allows us to move our object around. And you'll see that there are 3 different arrows, okay? The green arrow is basically for the y-axis, so that goes up and down. The blue is for the z, that moves forward and back. And the green and the red arrow is for the x-axis, and that moves us left and right. Now, look what happens if I click and drag on the blue arrow. You can see it gets highlighted in yellow, and I can drag it along the z-axis. And if you look in the inspector while I'm doing this, you can see that the z value of our position is changing, okay? It's in the negatives, and then we can bring it over into the positives if I drag it a bit further along. Also for the Y, we can do that as well. We can click and drag, and for the x-axis, we can do the exact same. So yeah, that is how we can move an object along its individual axes, like so. We can also go ahead and modify that directly, so I can set the x-axis in the inspector to be 0. It's going to move it over there. So if you want more precise numbers, you can do it that way. Also, in the inspector, you can hover over the individual axis headers. So if I hover over X, you'll see this little icon pops up over my mouse. I can click and drag to sort of adjust it here as well. Okay, so you can quickly adjust it just by using the inspector. Let's just say you just want to move your object along a flat surface. Well, you'll see on our object here, we have these 3 different little squares. Now, if I click and drag on the bottom one here, you can see that I'm moving the object along both the X and the Z axis. Okay, so we're moving along a single plane of direction. We can do the exact same thing for this red one. This moves us along the Y and the Z plane. And finally, the blue one, which moves us along the X and the Y plane. So yeah, those are just a number of different tools that we can use in order to position and move our game objects around in our 3D world. Now, what I'm also going to do is I'm going to right click in the hierarchy, and I'm going to create a 3D object sphere, and we can then move these objects along and just experiment with positioning them in our scene. Now, one more thing, and that is how can we delete objects? Okay, let's just say we don't want our sphere anymore. How do we get rid of it? Well, what we can do is we can go to the hierarchy, right click on our sphere game object, and then go down to delete, okay? We can also do Control Z or Command Z if you're on a Mac in order to undo your actions, or we could just click on the object and press the delete key on our keyboard, okay? So there we go. Now, in the next lesson, we are going to continue looking at how we can orientate and move these objects around by looking at how we can begin to rotate our game objects, okay? So we've looked at moving them around, but how about rotating them? Well, we'll be exploring that in the next lesson. So I'll see you all then. Welcome back, everyone. In this lesson, we are going to be looking at how we can rotate objects inside of Unity. So in the previous lesson, we looked at how we can move objects around along the X, Y, and Z positions. Now, in this lesson, we're going to be looking at how we can rotate them. So what I'm going to do is I'm going to create ourselves a new object. So I'm going to right click in the hierarchy, go 3D object, cube, to create a brand new cube right here. And to get over from the move tool to the rotate tool, what we can do is go into the left-hand side of the scene view, and you'll see there is a rotate tool button right here. We just want to click on that, and it will change. Now you'll see we now have a different gizmo appearing above our cube. And it looks a bit similar, okay? We still have the exact same colored identifiers like we had with the move tool. We have the blue here for the Z-axis, we have the red here for the X-axis, and the green for the Y-axis. Now, if I click and drag on one of these rings, you'll see that we can rotate this object around the Y-axis, for example, and you can see in the inspector that value is also changing. Now, in the inspector, this rotation value is in terms of degrees. So if I put the Y at 0, that is going to be 0 degrees along the y-axis. If I set this to 90, it is going to be a 90-degree turn. So that's why the cube doesn't look much different. Whereas if I put it at 45 degrees, you can see one of the edges is on a bit of an angle. Now we can also rotate it along the x-axis by clicking and dragging on the red, and we can do the exact same by clicking on the blue to rotate it around the z-axis, okay, just like so. And of course, you can manually assign a rotation, so we can click and drag on the little X text right here in order to rotate it smoothly, like so, or we can go in and manually assign a value, something like that. Now, also with the rotation tool right here, we can just click in the middle. So if you're not hovering over any specific line, you can just click in the middle and it will sort of free rotate around your mouse. Now, this isn't very precise, but if you just want to get a sort of random rotation on an object, you can just click and drag, move it around a bit, and then you can get a random rotation, something like that. Okay, I'm just going to undo this with Control Z. There we go, back to 0, 0, 0. And you can also see that there is a white circle surrounding it. It might be a bit hard to see, but there is a white circle surrounding all the others. And if we click and drag on that, it will rotate this object relative to where our camera is facing. Now, something else that we'll probably want to go over is the idea of world space versus local space. So let's just say I rotate this object a bit, like so. Okay, so we have it on a bit of an angle. And then I go over and press W as a shortcut for the move tool. Okay, you can also press E to toggle on the rotate tool. So E for rotate tool, W for move tool. You'll see that our move tool has now rotated along with the cube. Okay, the green arrow, which is our Y, our up and down, is not facing vertical anymore. It is now facing vertical relative to the cube's rotation. So if I go back to press E and rotate it a bit more in this direction and maybe a bit in this, press W, you'll see that our move tool is now orientated relative to the cube, okay? And we can of course click and drag to move it along that relative direction. Now, this can be great for some instances, okay, if you want to rotate an object and move it along its relative directions, but other times you might want to still move it in terms of the global direction, okay, the globally defined up, the globally defined right, and forward. Well, to change between the two, we can go to the top left corner of our scene view window and click on this second drop down where we can switch between global and local. Okay, right now we're on local, so our tools are going to be positioned and rotated relative to whatever object we are on. Whereas if we click global, the gizmos are going to be relative to the world. Okay, they're going to be based on world space rather than local space. So now we can move this rotated object along like so. We can also rotate it a bit more, and you see that the move tool does not change orientation. Okay, it sticks into its original direction and we can move it around just like before. Now also note that if you are modifying the position values, the position values here in the inspector are always in global space. So for example, if I were to move along the Z axis with the move tool, you can see I'm moving along this direction here. But if I modify the Z axis in the inspector, you can see that we move along the global Z axis, okay? So yeah, that is a look at rotating and also a look at the local and global space inside of Unity. And we'll be looking at the local and global space a bit more in detail later on once we start looking at what's known as parenting. But for now, this is the rotation tool. We can press E as a hotkey to it, or we can click on it here in the scene view, and we can rotate our objects around to whatever orientation we wish. Now, in the next lesson, we're going to finish this off by looking at how we can change the scale or the size of our game objects inside of Unity. So I'll see you all then in the next lesson. Welcome back everyone. In this lesson, we are going to be looking at scaling game objects inside of Unity. So here in the editor, what I'm going to do is I'm going to create ourselves a brand new cube. And with this cube, what we can do is we can go over to the scene view here on the left-hand side and click on the scale tool right here. Okay, and this is going to toggle it. Now, it looks a lot like the move tool, yet you can see instead of arrows, we have little cubes at the end. And if we click and drag on them, they are going to change the scale of our object in the inspector. You can see that's happening along the Z-axis here. Same thing for the X and for the Y. Now, scale basically defines the size of the object, okay? Unlike rotation and position, so if I set the position to 0, 0, 0, and the rotation to 0, 0, 0, you'll see that our position is in the center of the world and our rotation is not rotated. Yet if I set the scale to be 0, 0, 0, you'll see that it doesn't exist, and that's because the default scale is not 0, rather it is 1, okay? And I think a good way of thinking of scale is in terms of percentages. You can think of the default 1 scale as 100% of its own size, okay? Because whatever 3D model, whatever sprite or effect you might have as the game object, that is going to be 100% of its normal size. So 1 is the default. And if I were to change it to be 2, then that means that this object is now twice as large, okay? Instead of being 1 size, it is now 2 size. We can bring that up to 5, and it is now 5 times as large. So scale does differ in that way, but apart from that, it behaves in pretty much the exact same way, okay? Just like when we can press W to go to the move tool, E to go to the rotate tool, we can also press R for the scaling tool, okay? And we can also click on this little cube in the middle of the tool right here, and this is going to basically scale up all of the axes uniformly, okay? As you can see here. Now, over in the inspector, we can of course modify these values individually as well. So if we want to make this cube half its normal size, we can go 0.5 on each of these X, Y, and Z axes. Now, you also see that there is this little icon next to the scale property. And what this does is it basically enables proportional modifying of these values. So if I click on it and then change the value of one of them, you can see they all change as well. Whereas if I disable it, we can also then go ahead and just modify individual axes. Because generally when you're scaling objects, you probably want to scale it along all of the axes uniformly. For example, you might have a 3D model of a tree. Now, you don't want to scale the tree along its x-axis, okay? Otherwise it would be very wide. And you probably don't want to scale it along its y-axis, otherwise it'd be stretched out. Rather, you'd probably want to scale your 3D models along all of the axes so that they maintain their proportions, okay? So yeah, bring this back to 1 here. So now that we have an idea of the movement, rotation, and scaling tools, I think it's time for a bit of a challenge. So this is the challenge that I want you to complete, okay? Using the move, rotate, and scale tools, I want you to create a stick figure as you can see here in this image, okay? It is constructed using a number of different cubes as well as a sphere for the head. So you'll be needing to create these game objects, you'll be needing to move them around, you'll also be needing to scale and rotate them as well to get them in the correct orientation and size that you wish. So have a go at the challenge and I'll be right back to see how you're done. Okay, so I hope you had a go at the challenge. Let's hop over back into Unity and have a look at how we can complete it. So first of all, we need to create our objects. So I'm going to right click on the hierarchy. I'm going to go 3D object cube. Okay, so we have our cube right here. What I'm going to do is I'm going to move it up here a bit. I'm also then going to press R to toggle the rotate, to toggle the scaling tool, and I'm just going to scale it up along the y-axis right here, okay? And this is going to be our main body. So I'm going to move that up like so. I'm then going to create another cube, but it's going to be a bit of a hassle to go ahead, create another cube, position it, rotate it, scale it. Instead, what we can do is duplicate this selected object. So with an object selected, I'm going to go Control D, and that is going to make a copy of it, as you can see. So then I can just move it over here. I can scale it down a bit, rotate it for the leg, like so. Duplicate that again, rotate it the other direction, move it over like that. Then for the arms, I'm going to duplicate the body here. I'm going to rotate it along like so, You can then also scale it down a bit, stretch it out a bit, move it up. And then what we can do is create the head. And for the head, we're just going to be creating a sphere. So I'll create a sphere like this, move it over into position. Probably need to scale it up uniformly quite a bit. And there we go. So now we have ourselves our stick figure like so. Okay, it's got its head, it's got its arms, it's got its legs, its body. And we've done this using both the rotation, movement, and scaling tools. Okay, so have a go at this, create some other stuff as well, just so you get used to the workflow of being able to move, position them. And also if you want more finer rotations, we can go over, for example, the arms here, they might not be exactly straight. So I can go over to the inspector and change the Z rotation. You can see we got an extra 0.55. I'm just going to make it -90 exactly, and there we go. So yeah, go through, create some other models if you wish. And in the next lesson, we are going to be going over the concept of parenting game objects inside of Unity. So thanks for watching, and I'll see you all then. Hey everyone, and welcome back. In this lesson, we are going to be looking at parenting inside of Unity. Now, also known as object parenting, this involves two terminologies, parent and child. Now, the way parenting works is that you have a parent object which can have children objects, and these children objects inherit the position, rotation, and scale of their parent. So let's hop over into Unity right now and have a look at how we can set this up. So as an example, let's go ahead and create a brand new game object. So I'm going to go over to the hierarchy, I'm going to right click, down to 3D object, and I'm going to create a capsule, okay, something like this. Now we can select the capsule, and over in the inspector we can change the name of it to be, let's just say, player, okay. This is going to be our player object for this example. Then down in position, let's set the position to be 0 on the X, 0 on the Y, and 0 on the Z, just so it's a bit more organized. Now we have our player here, right, and we can move it around like so. Now, let's just say our player wants to be holding an item. This might be a piece of clothing, it might be a weapon, it could be anything that we want to sort of attach to our player. Well, for this, we can of course create another game object. So I'm going to right click on the hierarchy, go 3D object, cube, and let's rename this to be item. Now, I'm going to position this as well as 0, 0, 0, move it forward a bit. I'm going to scale it down, let's just say to 0.5. For the scale, and just position it sort of like this, right? So we have our player, we have them holding or wearing an item. Now, of course, we'd want to move our player around. So we can select our player, move them around, but as you can see, the item doesn't move as well. So what we could do is, we could move the player, then move the item, but that's quite convoluted. So a way we can make it so the item follows the player is by making the item a child of the player. Okay, so how do we do that? Well, what I'm going to do is I'm going to select our item. I'm going to click and hold so that our mouse cursor changes like so. I'm then going to hover over player and let go. Okay, we're basically dragging item into player. And as you can see, something here in the hierarchy changed. Item is now indented and it is now a child of player. You can see on player it has this little drop down arrow which we can toggle to basically show and hide all of its children objects. So the item is now a child of player. So if we select the player and we start moving it around, you will see that the item basically sticks to the player, okay? It is inheriting its position. Now we can also go ahead and rotate the player, and as you can see, that cube is also rotating along with our player as if it is stuck to it. And just like with rotation and movement, we can also scale it as well, and that will scale up proportionally too. Now, how is this working and what is going on? Well, pretty much the item object, it knows that its parent is the player. So basically it sets its position to be whatever the player's position is, plus whatever offset we set here in the transform component. Okay, you can see here that the offset on the X is 0, the offset on the Y is about 0.26, and Z 0.52. Now, look what happens if I select our player and I move it all the way over here. Okay, you can see the X is like 14 and negative 11 on the Z. But if I select the item, you'll see that its X position is still 0 and the Z is only 0.5, even though we are pretty far away from the 0, 0 point in our world. And that is because this transform component is not showing its position relative to the world. Okay, it's not showing the global position, rather it is showing us the item's local position relative to the player. Okay, it is 0 units away from the player's X, and it is 0.268 units away from the player's Y origin. Okay, so whenever you have a child object, the transform component is not showing you the global values for the position, rotation, and scale. Rather, it is showing you the local values that are relative to whatever the parent object is. So if I go ahead and rotate our player around like so and scale it up a bit, you'll see that the item still has 0, 0, 0 on the rotation because relative to the player itself, it hasn't rotated at all. And the scale is still 0.5 because relative to the player scale, our cube is still half its normal size. Okay. Now, that may take some time to get used to, understanding how object parenting works inside of Unity, but it's something that you'll be using so often that over time it'll just start to click. Okay. Now, something else I think we should go over, and that is the idea of an empty game object. Now, to do this, we can just right click and go create empty. And an empty game object is pretty much what it sounds like. It is basically a game object with no components. Oh, well, we do have the transform component, but that is a necessity for everything. But there is no other components, okay? There's nothing defining what this is. And an empty game object can generally be used as the parent object for a lot of things. I generally like to use a parent game object for my player and then have the 3D model as a child, have the camera as a child, and any other items that we want the player to be holding as a child of that. Okay, I just prefer that for organization and it's generally a good workflow. Okay, so as a bit of a challenge, what I want you to do is I want you to create a sword which we can move, rotate, and scale with it all being a single unit, okay? So in this case, what we would do is we would probably have an empty game object, and as a child of that, we would have a number of different 3D models, which represents the sword, as you can see here in the image. And then by clicking on that parent, we should be able to move it around, rotate it, and it should basically act as an item that our player could use. So have a go at that challenge, and I'll be right back to see how you're done. Okay, so I hope you had a go at that challenge. Let's go ahead and look at how we can accomplish it. So, over inside of Unity, what I'm going to do is I'm going to start off by creating ourselves an empty game object to sort of act as the parent, okay? Now, the reason why we're doing this is because this also allows us to decide where the origin or the pivot point for our object is. So I'm going to right click, go create empty, and I'm going to call this one our sword. Let's bring it over to 0, 0, 0 just to make it nice and organized here. And what I'm going to do is I am then going to right click on the sword. Okay, as a bit of a shortcut, we can right click on the sword object here in the hierarchy, go 3D object, cube, and that will create a cube and automatically make it a child of sword. Now, with this cube, we can resize it a bit, and I'm going to make this the handle, okay? We can then duplicate that cube with Control D. We might then drag it out a bit like so. Move it up here. Okay, and then for the blade, we can just duplicate this once more, drag it up, scale it up a bit, like so, and there we go. Okay, so we have a very basic sword right here. Now, what we can then do is select the sword parent object here, and as you can see, where the move tool is that's basically what's known as the origin or the pivot point for this object, okay? So whenever we move it, it is going to have that as the origin point for where the location is, and we rotate around that point as well. So we could then, have it as our player's weapon and then swing it around like so. And you'll see how all of the children objects follow along in suit. Now, something else I want to go over before we continue, and that is understanding that objects can have pretty much as many children as they wish, and those children can also have children, okay? So it's a hierarchy in a sense. So what we could do is we could go ahead, create our 3D object capsule once more, okay? Bring that over to 000. Let's call this one player. And what we can then do is drag the sword in as a child of player. Set the sword's position to be 0, maybe move it over here a bit, rotate it like so, and there we go. Our player is now holding a sword. It's pretty big, but there you go. And you'll see in the hierarchy that our player is the parent of the sword, and the sword is the parent of the 3 cube objects, okay? So you can basically make this tree of parent-child relationships that pretty much extend as far as you need, okay? And this sword then might have some sort of, magical effect that you might want to attach to specifically the blade and then have that as a child of the cube. And yeah, you can get into a lot of detail and have a lot of children objects of parents. Yeah, you'll definitely be going over this quite a bit when creating your games, as generally parenting is something that is used in many, many circumstances. So thanks for watching, and I'll see you all in the next lesson. Hey everyone, in this lesson, we are going to be looking at materials inside of Unity. Now, what is a material? Well, basically, materials define how an object is rendered to your screen, okay? The color of the object, the texture, the roughness, how metallic it is, and how it reacts to light. And there are many different other things that materials can do. If ever you've played a game, you would of course noticed that there are many different types of surfaces, okay? You may have water, which is slightly transparent, and it might reflect some of the light. You might have a tree, which is rough with a bark texture. Those are all materials, and those are defined by the game developers in order to tell your computer or your console how those objects should be rendered to your screen. So let's hop over into Unity right now and have a look at how we can create some materials. So here inside of Unity, what I'm going to do is I'm going to start off by just creating a brand new sphere game object. So I'm going to right click on the hierarchy, go 3D object, sphere, okay? And what you'll notice is this sphere has a pretty bland appearance, okay? It's white. You can see that the directional light over here is basically casting a light on the sphere. So it's very bright here and dark over here, okay? If we look at the directional light, you'll see the direction it's pointing with the blue arrow. And what we can actually do is on our directional light, we can go to the inspector and click on this little selection box here to basically enable and disable the light. And you'll see if I disable it, the lighting disappears. So by default, this sphere has a very simple material where it reacts to the light and it has a smooth white finish. So how can we create our own material? Well, down here in the project browser, what I'm going to do is I'm going to right click, I'm going to go up to create, and then over to material down here, okay? And I'm going to call this one, we'll just call it my material. Now, you'll see that when we create a material here, this is basically creating a new asset inside of our project, okay? This is now a file on our computer and we can use it in Unity here. So we have our material. Now let's click on it with left mouse, and you'll notice that over in the inspector, we have a lot of basically properties available to us, okay? And this is where we can modify the material. So you'll see we have things like albedo, metallic, smoothness, normal map, height map. Now there is a lot of stuff here to experiment with, but really we are only going to be focusing on the albedo and the metallic and smoothness, okay? Albedo is basically what color this material is. So if we click on this white box here, it's going to open up a little color wheel. So we can make it a red color, for example, and you'll see down here in the little preview window, we can click and drag on this to increase it in size. We have a preview of what our material looks like. So we have this red material, but how do we actually apply it to our sphere? Well, that's pretty easy. All we have to do is click and drag on the material in the project browser, and hover over our sphere and let go. Okay, we're basically just clicking and dragging it on. And now our sphere has that material. And something else that's pretty cool is anything we do to this material file right here, those changes will automatically be updated to our sphere. So let's just say we want to up the smoothness a bit. We can click and drag on this smoothness slider and bring that to 1. Okay, and you'll see right now our sphere is very reflective and it's reflecting the skybox in the background. Or if we want it to be a rough surface, maybe this is like some stone or wood, we can bring that down to 0 and it becomes a very non-reflective surface. Now, as well as smoothness, we also have metallic, which basically defines, how metal-like this object is. I'm just going to put that on 0. And something else we can also do is change the transparency of this object, okay? Because right now this is an opaque material, and you can see here, if we select our material, you'll see that we have the rendering mode set to opaque, okay? And opaque basically means it is a solid object. Well, if we click on opaque, you'll see there are a number of different rendering modes that we can choose. We have cutout, fade, and transparent. Now, if we want to be able to see through this object, we can select transparent, for example. And you'll notice that nothing really changes here. But if we click on the albedo color once more, okay, we can of course change the color just like before. But now what we can also do is go down to these 4 values, okay? And you'll see here we have the color wheel, and then we have the values RGBA. Okay, we have the red channel, which defines how red this object is. We have green and blue. And you'll see that when I change the color, those red, green, and blue values will change as well. And with those 3, that is basically how we can define colors. Now, how do we make it transparent? Well, we have one final channel here called the alpha channel, and that defines transparency. If we click and drag on this, you'll see that the sphere is becoming more see-through as I drag that down, okay? So full opaqueness at 255, and if I bring that down to 0, it's invisible, although with the transparency render mode, it does appear slightly, okay? But yeah, that is how we can use transparency inside of our materials. Okay, so as a bit of a challenge, I want you to complete these 3 materials that you can see on screen, okay? We have a reflective red material, we have a very rough blue material, and then we have a transparent green material. So yeah, have a go at that challenge, and I'll be right back to see how you're done. Okay, so I hope you had to go at that challenge. Now let's hop over back into Unity and have a look at how we can create these 3 materials. So first up, what I'm going to do is I'm going to create our 3 spheres. So in the hierarchy, I'm just going to right click, go 3D object sphere. I'm then going to go Control D to duplicate it and move 2 over like so. All right. Now down here in the project window, what I'm going to do is I'm going to right click, I'm going to create a new material. I'm going to call this one our shiny red. I'm going to click and drag it on our sphere like so, okay? And by default, the material that you create is going to be this white material. So it does not look like we're applying anything, but we are. So we can click on that shiny red material, go over to the inspector. We can change the albedo color to be red, and we can then up the smoothness value, okay? So it is now very reflective. So that's how we can create the shiny red material. Now, how about the rough blue? Well, let's create a new material here. I'm going to call this one rough blue. I'm going to drag it onto the middle sphere. And then for this one, I'm going to change the albedo color to be a blue color like so. And I'm going to bring the smoothness value down to 0, okay? So now it's pretty much not reflecting anything whatsoever, unlike the red one over here. And then finally, we have the transparent green color. So I'm going to create a new material. I'm going to call this one see-through green. And then we can drag that on like so. Now for this one, I'm going to set the albedo to be green. I'm going to bring the smoothness down to 0 as well. And over in rendering mode, we can switch this over to transparent. Click on the albedo color once more, and we're going to bring the alpha channel down to about halfway, okay? And there we go. So if we actually move over a bit, we can see the blue through the green as well. So we know that it is working correctly. So yeah, that is how we can create these three materials inside of Unity using Unity's material system. Pretty much what we're doing is we're going down to our project browser. We are creating a new file, which is a .mat file, which is material. We are applying some changes to the list of properties here, and then we are dragging that on to an object that we want to assign. Now, a way we can also assign a material is if we click on an object, okay, and if it has a mesh renderer component, that means we can assign a material. So over here, you'll see that we have a materials dropdown. If I click on that, and we can see the material that has been assigned, okay, the rough blue. Now, we can also then click and drag on a material and drag that into the property here, okay? So if you don't want to drag that onto the object itself, or if you've selected an object that you're not sure exactly where it is, but you want to assign a material, you can just do that over in the mesh renderer component, okay? Click and drag into the materials property right here. Alternatively, you can also click on the little circle next to the material property to open up a window which basically shows you all of the materials available to you in your project. So we have our three materials right here, and we also have some other default ones that come with Unity as well. So yeah, that is a quick look at materials inside of Unity. There is definitely a lot more to them, as there are entire jobs out there in the games industry relating to materials. So feel free to explore. You can even import some textures of your own and apply them. There's lots of different ways to discover and learn about materials. So thank you for watching. Hey everyone, in this lesson we are going to be looking at prefabs inside of Unity. So let's hop over to Unity right now and get started in learning what a prefab is and how we can use them. Pretty much, prefabs are game objects that we can save to our project files and spawn them in later or create many copies of them. Okay, they're basically templates that we can use in our games. So first of all, what I'm going to do is I'm going to go into the hierarchy here. I'm going to create ourselves a brand new, we'll make a cube here, okay? And I'm going to call this one, we'll just call this one test prefab, okay? Now with this cube, I'm also going to go to our project browser and create a new material. I'll just call this one my mat, drag that on like so, and I'm going to change the smoothness down and we'll just make it red, okay? Like so. So we have this red cube right here. Now, what we can do is we can then click and drag on this test prefab and bring that down to our project window. And if we let go, a couple things are going to happen. First of all, you'll see that a new file has been added to our project browser right here called test prefab. And you'll also notice that in the hierarchy, our object is now blue, okay? It has a blue icon and a blue name. This means that it is a prefab. And down here in the project browser, we have the prefab file itself. So how does this work? Well, pretty much what we have done is we have created a template for a game object, and this blue object in our scene right now is an instance of that prefab. So let's just say we have a game and we have an enemy, right? We create an enemy game object, we set it up so that it can start chasing around our player, it has effects and everything on it. Now, what happens if we want to start spawning in a bunch of different enemies around our level? Well, we could, of course, get the game object, copy and paste it around, but what happens if all of a sudden we want to change the enemy's move speed, for example? Well, we'd have to go through each of those game objects, modifying their move speed, and, if we have a couple hundred of them, that's going to take forever. So instead what we can do is we can turn that enemy object into a prefab, and if we want to make a change to all of the enemies in our game, we only need to change the prefab, and all those changes will then get applied to every instance. So I'll show you what I mean. Down here in our project browser, I'm going to select the test prefab and drag that into our scene window. Okay, and as you can see, it has created a new game object, which is our test prefab. I'm going to drag in another one here. And there we go. So we have 3 of these cubes now. And you'll see in our hierarchy, we have test prefab 1, 2, and test prefab. And they're all blue, meaning that they are prefab instances. So let's say that we want to change the size of this cube. Okay, let's say we don't want this cube to be this size anymore. We might want it to be a bit bigger. Well, we could go through, select this prefab, select this object right here, change the scale to 1.5 a bit, select this one, scale that up, select this one, scale it up. But if we have, hundreds of objects, this might be a tree or a rock in our level where we might have, thousands of them around the place. In that case, what we can do is we can just go over to the prefab file and modify the values here. Okay, so pretty much any change we make to this prefab, those changes will be applied to every instance of that prefab. So if I go in here and change the scale to be, let's just say 1.5 on the X, 1.5 on the Y, and 1.5 on the Z, you'll see that those changes get instantly applied to these 3 cubes, okay? Because these cubes, remember, these are an instance of the prefab file right here. So they are basically looking to this prefab in order to know what they are. And any change we make to that prefab, those changes will also be applied to the instances. So again, this is just a great way of structuring your game. Whenever you start making a game and you have an object that you want basically more than one of, it's recommended that you make it a prefab, because later on, let's just say you have a door in your game, for example, and you have a bunch of doors around the place, and you're playing the game and then you decide, you know what, I want the door to open up a bit faster when the player runs through it. Well, instead of going through each and every single object that is a door and changing that value, you can instead just change one single value in the prefab, and those get applied to every instance of that door. Okay, so we can change this back to 1, like so, and of course those changes do get applied. Same thing for materials, okay? If we change the material right here to, let's just say, default-material, those materials get applied to the instances as well, okay? So any change that you make here inside of the inspector when selecting the prefab, those changes will be applied to the game object. And as well, if this game object or if the prefab has child objects, those also get assigned and applied as well. Now, what if we actually want to go ahead and edit the prefab? What if we want to maybe add more objects to it that we can't really do in the inspector here? Well, something that's pretty cool is we can just double click on our prefab and it will open up this sort of editor right here. And this is basically where we can add more objects to our prefab, change them around, etc. So in the hierarchy here, you'll see we have test prefab. I can right click on that, go 3D object, let's just say a sphere. We can then move the sphere over like so. Maybe we want this to look a bit like that. Okay, so we have a cube with a sphere. Now, if I click on the little back arrow here in the hierarchy, that'll take us back, and those changes that we made in that editor will be applied to our prefab, okay? And as you can see, each of our instances now have that extra sphere added to them. Okay, so hopefully you can see how great prefabs are, and hopefully you'll be using them throughout your entire project, okay? And they definitely do help when making your games. So, test out the prefabs, make your own, experiment with them, and thank you for watching. Hey everyone, in this lesson, we are going to have an introductory look at lighting inside of Unity. So as you can see here, I've gone ahead and just created a little environment where I've got a 3D plane with some cubes on top, and I've also applied a material to these objects as well. Now, by default, in your Unity 3D scene, you should have a directional light game object. Now, this directional light basically acts as the sun, okay? It has parallel rays of light going in a specified direction, and you can even see on these cubes here, they are casting a shadow based on the direction of the directional light. Now, if we go and press E to go to the rotational tool, we can click and drag on this directional light in order to change the direction that this light is shining, okay? And we can even rotate it up, and you can see our scene goes dark because it's basically simulating nighttime. And we can rotate that around however we like. So there you go. Now, the directional light doesn't matter which position it's in. It only really matters the direction it's facing, okay? Now, if we select the directional light and look in the inspector, you'll see there are a number of different properties in the light component. For example, we have the color, which we can select and modify on the color wheel right here. We can have a green sun, for example. We can have a blue one. We can have a pink one. You can really change it to whatever color you wish. We also have the intensity, which defines how intense our light is. As you can see, I can bring that number up and it gets very bright. We also have shadow type, so we can change our shadows from being soft shadows to hard shadows, which may run a bit better on certain devices, and no shadows if you want to have no shadows available, which could help with performance. I'm going to swap that back to soft shadows. And then there are some other options as well, but lighting can be a very advanced topic if you go deep into it, so we're not going to look too much into that, okay? But as well as directional lights, Unity also offers a range of other types. So if I right click here in the hierarchy, I can go down to light, and you'll see here we have some others, okay? We can select point light, and this basically is a light source that emits in all directions around it. So something like a candle, for example, would have a point light like this. You can move that around and you can see the light changing as it goes. Let's change the color. Actually, let's make it a candle. So let's change the color to an orange. We might want to then up the intensity a bit. And with the point light, we also have a range property. And if we zoom out a bit, you'll see that there is this circle around our point light. And that basically defines the range of the light. Now, if we go to the edge where we have these little cubes, we can click and drag on those to increase or decrease the range of our light, or we can change the range property here in the inspector. Okay, so that is the point light. Let's move that over there. And the next light that we're going to be looking at is the spotlight. So we can right click in the hierarchy, go light, spotlight, and this is something that you would use, for example, if you have a torch or something that you want to cast in a certain cone. So you can see the spotlight has a cone that emits from its position, and the rotation determines which direction it is facing. So with the spotlight, we can rotate it. We can go over and click and drag on these little cubes at the end of the cone to increase the angle. We can even increase the range of it as well here, or we can do that over in the inspector respectively. We can change the color, so we might want to make this a green light, change up the intensity a bit, and yeah, basically, there are lots of ways to set up lighting here inside of Unity. These are probably the most common ones. A directional light, if you're having an outdoor setting, you'll most likely have a directional light. If you're indoors, then you might have point lights lighting up your environment, as they might be in light bulbs, or they might be candles or flames. And if maybe you have a street lamp, or you have some cars, or your player is holding a torch, then you might use something like a spotlight. So yeah. That is just a basic overview of lighting inside of Unity. One thing to be wary of though is a lot of lights can impact your performance, and generally lighting is one of the most performance heavy things that you can have in your game. So do keep an eye out for that, but generally it should be pretty good if you go light on the lights. So thanks for watching, and I'll see you all then in the next lesson. Hey everyone, in this lesson we are going to be looking at physics inside of Unity. So let's hop over to the engine and begin to have a look. So in Unity and many other game engines, they have physics capabilities, meaning that the things and elements and game objects in your game can interact with each other with physics. So if you would have a hill, you'd be able to spawn some spheres and have them roll down, okay? So things like gravity, friction, velocity, and various external forces can be applied to your objects. So how do we get this working in Unity? Well, to start, I'm going to go ahead and create a new 3D plane, which is basically a flat ground. So I'm going to bring this to 0, 0, 0 here. So we have a flat ground. I'm also going to go ahead and create a material just to make this look a bit different. Just call it ground, drag that on. Set the albedo to a darker color, like so. Bring the smoothness down. And now I'm going to right click. I'm going to create a new 3D sphere. And I'm going to move it to the center here. Now, when we press play, we're going to switch over to our game camera. So let's actually orientate this in a position that we want. So I'm going to move it up about here. There we go. So we have our sphere. Now, if I go ahead and click on the play button, what you'll see happen is not much, okay? It just sits there because it is a game object. It doesn't know what to do. It's just a sphere sitting there. So what we can do is attach a component that gives this sphere physical capabilities. And to do that, we can go down to add component once we have the sphere selected. And we are going to add in a component called a rigid body. So select that. Let's actually close up the mesh renderer here and the mesh filter since we won't be needing those. Now, the rigid body component basically applies physics to the game object, okay? You can see here we have properties for mass, drag, angular drag, whether or not we use gravity. So if we go ahead and press play, what we should see is the ball then falls to the ground. As you can see, it's sitting on the ground. So the way this works is with a sphere collider, okay? It's important that if you do have a rigid body component attached, that you also have a collider component as well, because if your object doesn't have a collider, then there's no real point of it being a rigid body, right? Because it's not going to be ever able to hit anything or roll or have friction. So the sphere collider is basically what defines the physical boundary of the sphere. If we go to the scene view here and go in a bit, you'll see we have this green wireframe around, and that is the sphere collider. We can increase and decrease the radius of that if we wish. So if the 3D model is a bit not exactly to fit, we can change the sphere collider to match that. And the rigid body applies physics. So let's just say we want our sphere to roll down something. Well, what we can do is we can create a brand new cube here. Okay, I'm just going to make a nice simple little ramp. So I'm going to bring this underneath our sphere. I'm going to scale it a bit like so, and then rotate it like that. Okay, so we have this nice little ramp. So now if I press play, what you should see is the sphere hits the ramp and it rolls down the hill and then off the edge. Okay, so that works. Now, something else we can do on our sphere is change its settings, okay? Things like drag. Now, drag basically determines the wind resistance on this object. At a drag at 0, that basically means we're in space, and if you apply a force to an object, it is going to maintain that velocity until something else changes it, okay? Because drag isn't going to slow it down. Whereas down here on Earth, if we were to apply a force to something, like throw a ball, that of course would be affected by gravity, but the speed would also be affected by wind resistance, okay? The wind hitting that object and slowing it down. So for the drag, we can set this to, let's just say 1, and what we should see is that this ball is all of a sudden going to roll down here, and just before it gets over the edge, it stops, okay? Because that momentum has been slowed down by the drag. So that is one way we can apply physics to an object. Now, there's also a bunch of other stuff here, such as interpolate, collision detection, but these are for more advanced things, such as maybe player controllers, which we're not going to be looking at. There's also a constraints tab here, and this allows us to freeze the object along its positional axes as well as rotational axes. So let's just say you want to have a physics object, but you don't want it to be rotate, okay? You might be making a player that you want to jump around, but you don't want the player all of a sudden to just fall over on its side when it hits a little bump, okay? In that case, you'd probably want to freeze the rotation along these axes here. But we don't want to do that since a ball, it needs to move in 3D space and it needs to roll. Now, the physics is also pretty realistic, so we could go ahead, duplicate this ball a bunch of times like so, and just see what happens, okay? So we have a bunch of those there, press play, and we should see them all interacting with each other like so. And yeah, it can be pretty fun to mess around with Unity's physics, adding in your own sort of things, maybe eventually have a player running around, hitting boxes, as it's always great to have physical interactions like this within your games. So yeah, that is just a quick look at the rigid body component, which applies physics to our game objects. You can also do the same for cubes and for any other object that has a collider attached, okay? It's important that your rigid bodies have colliders because otherwise they're not really going to be interacting with the world at all. So yeah, thanks for watching, and I'll see you all in the next lesson. Hey everyone, in this lesson we are going to have an introductory look into scripting. Now, scripting is a very important part of the Unity game engine, and it's basically what allows us to create our games. So, what is scripting? Well, basically it's how we create the gameplay behaviors and logic for our games. Now, scripting, it can also be known as coding or programming. Generally, those words can be interchangeable, although they do have their own specific meanings. But generally, when somebody says they are coding in Unity, that normally means they are scripting or they are programming. Okay, this is basically coding. We are writing code to give instructions to the game engine in order for it to do certain things. Okay, now a script is a file that we can create which contains code. Okay, think of like creating a new Word document or a new Notepad document. It is a file which contains the text of the code that we have written. So if we, for example, want to create a player controller which moves our player around, we would create our player controller script, and in there we would code all of the behavior for that player. Now, it's also important to note that a script is essentially a custom component. Okay, we are basically creating our own components inside of Unity whenever we create a script. So that means we have the ability to attach our scripts to game objects. Okay, so in the case of that player controller, we would essentially attach it or add it to our player game object, and then that script can basically interact with that game object, moving it around, and also maybe even communicating with other components that the player might have. Now, let's hop over into Unity and look at how we can create a script and how we can add it to a game object. So here I am inside of Unity. Now, the first thing we want to do is to go down to our project window here. And what I'm going to do is I'm going to create a script. So what we need to do is right click in our project window, go up to create, and you'll see here at the top it says C# script. So I'm going to click on that and you'll see it creates a new file. We can then give it a name here when it is highlighted. And I'm just going to call this one my first script, or you can really call it whatever you wish, and then hit enter and it will create it. Now, what is C#? Okay, and you'll see we also have this hashtag or pound icon on the file, and C# is essentially the programming language that Unity uses to write its scripts. Just like you have English, French, or German, there are many different types of programming languages, okay, or coding languages. And Unity specifically uses the C# programming language for us to write our scripts, okay? And that is what we are going to be looking at for the rest of the course. We're looking at how we can start writing code and get a better understanding of the C# language and how we can interact with Unity in order to make our games. So, we have our script file right here. Now, what can we do with it? Well, we could open it up and start writing code, but before we do that, let's go and look at how we can add it as a component. Now, basically, once we create our script, it is essentially all done for us, okay? It is automatically been added to Unity's list of components. So what we can do is if we go over to our hierarchy, I'll right click and create a new 3D cube here, okay? And all we need to do is select the cube, and just like adding any other component, it works the exact same way. So we can go to the inspector, go down to the add component button, and what we can do then is we can of course go through our list of all the components, or we can go to the search bar here and type in my first script, and here you'll see it pop up. We can click on it and my first script will be added as a component, okay? So we can open and close it, we can enable and disable it, we can even right click and remove it, okay? It's basically a component that we have created. So we can also click and drag on the script file and bring that into the inspector to attach it like so as well, okay? So generally, if you don't want to go through the add component button, you can just click and drag your script onto a game object to add it quickly. So we have our component created. Now, how do we actually start writing code for it? How do we start writing logic so it can do something? Because right now, if we were to press play at the top here, we'd press play and nothing would happen. And that is because the script is basically empty. It contains no code, no logic. So how do we start writing that? Well, we just need to go down to our script file right here and double click it. And what that should do is open up the Visual Studio code editor, okay? Now, there may be an initial setup that you need to do where it may ask you to log in, and you can of course then log in with a Microsoft account or any other account that it provides. And once that script opens up, you should have Visual Studio open like so. Okay, yours may look a bit different just because I've changed the layout a bit, but generally you should have this program open. It may prompt you to log in. If so, just go through that process. And once it opens up, we should see our code right here. Now, Visual Studio is essentially a development environment, okay? This is a program which specializes in writing down code. Now, you could, for example, have Notepad or Microsoft Word as your code editor, yet that would be not a good idea because a program like this specializes in making writing code as easy and as comfortable as possible, okay? Things like autocorrect, automatic formatting, and coloring the bits of code to make it easier to read are just a few of the affordances that a program like this provides. So, initially, we'll see this bunch of code right here, okay? Things like using system.collections, public class, void update. Initially, you're going to look at this and have no idea what any of it is, and that's fine, okay? When starting out, code can be quite daunting, but what we're going to do in this course from here is go step by step, looking at the very basics, the foundations of programming and understanding the logic behind it so that we can then start creating our games, okay? And for most of this course, we are going to ignore a lot of this stuff here as that's really just a lot of the boilerplate stuff that we need in order to structure our script here. For now, we want our script or our component to actually do something. So what I'm going to do is I'm going to go over here to where it says void start. Okay, you see it says void start, and then it has these two little brackets, and then these squiggly brackets right here. Now, we're going to be going over this in a later lesson, but this is essentially a function, and it's basically a block of code which can run whenever we want. And you'll see after void start, it has these two squiggly brackets, and basically in between them, we can write some code. Now, the start function basically gets called once at the start of the game. So when this object is initialized, the start function will be called. So what I'm going to do is inside of start here, between the opening and closing squiggly bracket, what I'm going to do is I'm going to select. You should see it's automatically indented a bit as well. And I'm going to write debug.log. Now you should see when you're typing it, it pops up with this autocorrect window. So you can just hit enter and it will autocomplete whatever you're writing. And then in two brackets here, I'm going to put two quotation marks and just write hello. Okay. And then at the end, I'm going to put a semicolon to end that off. Now, looking at this, it's probably confusing. What's debug? What's log? Why do we have to put a semicolon here? We'll be going over this a bit later on, but for now, let's just get something working, all right? So debug.log. What we can do is we can go then Control S, or you can click on the little save button up here to save the script. We can then minimize this window and return to Unity. Okay, now nothing looks different. Our script is still here, but if you select the script, you'll see in the inspector we have a little preview of it, and we can see that that debug.log line is there. Now, if I press play, what you'll see is down here in the console, we have a new message, and that's because debug.log is essentially a line of code which allows us to print messages to our console, okay? So this basically allows us to see if the code works, and since it says hello down here in the console, we know that our script is working and it is running. So that is an introductory look at scripting inside of Unity. And in the next lesson and for the rest of the course, we are going to be going over the different fundamentals of programming and interacting with the Unity engine. So thanks for watching, and I'll see you all then.